How to calculate toughness from stress-strain curve. If you're curious about how to determine the toughness of a material using its stress-strain curve, you're in the right place. Let's break it down step by step. To start, you need to understand what a stress-strain curve is. This curve is a graph that shows how a material reacts when a load is applied to it. It plots stress, the force per unit area, against strain, the deformation per unit length. The toughness of a material is essentially a measure of how much energy it can absorb before it breaks. This energy is represented by the area under the stress-strain curve. Here's how you calculate it. First, you need to identify the different regions of the stress-strain curve. There's the proportional limit, where the material behaves elastically and follows Hooke's law. Then there's the elastic limit, beyond which the material starts to deform plastically and doesn't return to its original shape when the load is removed. To calculate toughness, you focus on the entire area under the curve from the beginning to the point where the material fractures. This area represents the total energy absorbed by the material. In practical terms, you can use software like Excel to plot the stress-strain curve and calculate this area. Here's a simple way to do it. Plot your stress and strain data on a graph. Use the area calculation tools available in Excel or other graphing software to find the area under the curve. This can be done by integrating the stress values over the strain values. The unit of toughness is typically measured in joules per cubic meter, JM cubed, or other similar units, depending on the system of units you're using. For example, if you have a set of data points for stress and strain, you can use Excel's built-in functions to calculate the area under the curve. This involves selecting the data points, using the chart wizard to create the graph, and then using Excel's area calculation tools to find the total area under the curve. It's also important to note that the stress-strain curve can have different shapes depending on the material. For some materials, the curve might show a clear yield point and a necking region where the material starts to thin and eventually fracture. You need to account for these changes when calculating the area. In summary, calculating toughness from a stress-strain curve involves plotting the curve, identifying the key points such as the fracture point, and then using software to calculate the total area under the curve. This area gives you the energy absorbed by the material, which is a direct measure of its toughness.